Okay, well, let's continue on with some science. Okay, that was my ode to Leonard. Hope you all enjoyed it. Okay, pure substances and mixtures. So, how do mixtures differ from pure substances? Of course, we know a pure substance is a single kind of matter. It has a specific composition, a specific makeup. And we know that we can break those pure substances down into elements or compounds. When we're talking about mixtures, we're talking about two or more things that have been mixed together. They're sharing the same place, um, but their atoms are not chemically combined. So when we're talking about mixtures, we're talking about homogeneous mixtures or heterogeneous mixtures. And of course, we know pure substances cannot be separated easily, but mixtures can. So again, when we're talking about pure substances, there are two types. There are elements, one kind of matter, and there are compounds, more than one element that has been chemically combined. So we've talked about bonding. We know bonding can occur through ionic, covalent, or molecular bonds. And so something that has been bonded would be a compound. There are very few things found in nature that are actually pure substances. Most elements that are found have been chemically combined in some way. Um, so things like nitrogen and oxygen, they are elements, but they're also found in air. They are mixtures that are part of the air. Metals like gold and silver can be found in things like ore. Now, if you're a researcher in the area of biology or chemistry, you may use pure substances. Um, that way, you can control very easily the variables of the experiment. And then you can tell which element is responsible for the results. And of course, we know that we need to make sure when we're doing experiments that we can relate those results to a single thing. Um, and you can get, again, pure substances from a variety of areas, plants, um, you know, a lot of barks of trees, flowers. And of course, those pure substances can then be used in the experiment. So let's move on to mixtures. You are more likely to have a lot of mixtures around you rather than pure substances. Again, there are two types of mixtures. There are homogeneous, and we know the prefix HOMO means the same, and there are heterogeneous, where the prefix hetero means different. And those help us describe the different types of mixtures. For instance, a heterogeneous mixture is when you can see the different parts that make it up. And you can look at this salad. You can easily see the different parts of that salad that are there. And then because of that, it's pretty easy to separate. With a homogeneous mixture, whatever is being mixed together, not chemically combined, but mixed together, appears to be the same throughout. So you can't necessarily pick out a part of the mixture. They're a little bit more difficult to see. And of course, depending on the type of mixture, we can separate them. Compounds obviously are difficult to separate because they are chemically combined. Mixtures are easier, again, because we can think about the different substances that are in that mixture and separate it based on its properties. So, something like a filtration, where we can separate a solid by pouring the mixture through a filter. And if you recall, we did that in one of our labs when we did our glue. We separated out the curds in the whey, or I'm sorry, our plastic, when we separated out our curds from our whey. If something has a magnetic property, we can separate out that magnetic object. For instance, if we mix iron and sulfur, iron's magnetic, and so we can separate it that way. Distillation. Liquids can be separated by heating them to the temperature where a liquid boils. Liquids boil at different temperatures, and so then based on the temperature, we can separate them. Evaporation. I mean, even something as simple as water and salt. If we leave it sitting out, the water is going to evaporate, leaving behind the salt. Okay, so Now, when we're classifying mixtures, there are a few different mixtures that we need to talk about. And we've touched on this already. There are solutions, there are colloids, and there are suspensions. And it is all based on the size of the particles in that mixture. Now, when we're talking about a solution, we're talking about a couple different parts of it as well. We are talking about a solute being dissolved into a solvent. And so it gets dissolved, the solute gets dissolved into the solvent, and it distributes pretty evenly. Water is a great solvent. Excuse me. It is called a universal solvent because it can dissolve so many different things. And of course, we know our life depends on water as well. Water is, again, a very common solvent, but solvents don't have to be liquids. For instance, gases can be. If we look at air, air is nitrogen gas with other gases dissolved into it. So even though we think of solvents as liquids, they don't have to be. All right, let's talk about colloids. Now, a colloid is a type of mixture that contains small undissolved particles, but they don't settle. They stay suspended. We can't really see them with just our eyes, but what they can do is they can scatter light. Milk, for instance, is a solid, or is a colloid, excuse me, because it can scatter light. Most colloids, then, because of that, are not clear. And then, of course, we have suspensions. A suspension is where the particles are large enough to be seen, but they will settle, or we can filter them out. Unlike a solution where the particles are dissolved evenly, a suspension doesn't have the same properties throughout. And we can see those visible particles in the solution. Okay, so again, the difference between the three is the size of the particle. And that allows us to classify whether or not something is a solution, a colloid, or a suspension. Now, how do we form these solutions? A solution is formed when particles of the solute separate from each other and become surrounded by the particles of the solvent. So here we have NaCl, sodium chloride, salt, and we have these little water molecules. And we can see the sodium and the chlorine have separated, still maintaining its properties though, and those particles get surrounded by the solvent, which in this case is water. Now, when we're talking about solutes, or what's being dissolved, we know that we create different types of bonds. We have ionic, molecular, ionic and covalent or molecular bonds. If we're talking about an ionic solute, like sodium chloride, the positive and negative ions are attracted to the polar part of the water molecule. We talked about how polar molecules have sort of this positive end and this negative end. Water is a polar molecule. And so the sodium and the chlorine, the positive and the negative, get attracted to that. When we're talking about molecular solutes, something like a sugar that's, covalently bonded, they break into neutral molecules in the water. And then the polar water molecules attract the polar solute. Now, because we are dissolving something into water, some things can then conduct electricity. Ionic solutes are going to conduct electricity. Molecular solutes are not, because we know electricity is conducted by ions. And of course, then, if we're dealing with an ionic compound or an ionic solute, then we're dealing with ions. And another thing that solutes can do is they can actually raise the boiling point of the solution above that of the solute. So solutes lower the freezing point of a solution below of the solvent alone. So that's why, a lot of times we put ice, if you lived up north, They put, in order to get rid of the ice on the streets, they put salt because it lowers the freezing point. So it keeps it a liquid, so it doesn't allow to freeze on the streets. Or we could add salt to water, which is going to increase the temperature where it boils. So the solute does affect the solvent that it's put into.